Before going to the next topic, couple of exercises. I kept some documents. Go to forOurSun.com, please. forOurSun.com/passion. You will see a directory called enabling acid on hive. Remember that hive never allowed us to delete the data because it is not a transactional system. The newer versions of hive are supporting transactional behavior to hive. So just to go through this document, some settings that you need to do, all the steps are mentioned inside that. That is one. The second one is there is a directory called hive, acid and avro. I think this document is already part of that directory also. So if you look inside that hive, acid and avro, as you can see on the screen, as a same document is repeated here also, so no need to download that one if you have not downloaded it. Okay. There are two files. Suppose by any chance you are working in a Cloudera environment. Cloudera has got a tool called Impala, which is allowing you to access hive. So that steps are written in that particular document. In your virtual machine it will work. Every screenshot, every command is written there. So just to go through these three, okay, because these are all very trivial things. You should not have any difficulty. If you feel any questions or anything, just let me know, okay, because everything is clearly mentioned inside that particular document, step by step. So once given hive, there is nothing. I usually do not discuss this, just create this document and then give to the people who are doing it. So, what's today? Today we are going to look at the next ingestion mechanism. Already we have completed scoop. The next one is Flume. Again, depending upon the environment, depending upon the company, you will be using this. It is not possible that everywhere Flume is available, but you must know it and you must know this because it's a very, very powerful tool. Okay, so come, cycle. So let's see what Flume is all about. About scoop, please remember scoop is used for RDBMS. Scoop is bidirectional from table to hive or HDFS, and similarly back. We have seen import as well as export, correct? Scoop is bidirectional. Flume is unidirectional, which means that you can only bring data. And normally Flume is used for files, whereas this is for RDBMS. See the difference. So if somebody is asking you that I have got my WebSphere application logs or Tableau logs or ab initio logs, I want to archive it into HDFS. I want to move that files to either Hive or HDFS. The answer is Flume. If tables, relational databases are involved, answer is Scoop. So different purpose, okay? And just imagine if I have an ab initio log and I am bringing it into HDFS, there is no sense in bringing the log from HDFS back to ab initio, correct? That is why it is unidirectional. You will not bring a log file back, right? But whereas tables, yes, you will bring it back. So Flume is only for bringing the data. Okay? Now, to understand Flume, please remember about three words: source, sink, and channel. Source, sink, and channel. Source is the place from where you are bringing the data. Sink is the place where you land the data, the destination. Channel is the pipe through which the data will flow. Without these three, you cannot create a Flume configuration. So to work with Flume, you need to create a Flume configuration. Flume configuration will tell three things: source, sink, and channel. So diagrammatically, if you represent, if this is the source, there is a pipe which is connecting the source, and let us assume that you are landing it here. This is the channel, sorry, this is the sink, and this way by which the data is flowing is called the channel. Source, sink, and channel. Okay? If you want to look at the diagrammatic way of doing these things, just go to Flume user guide. You will see all these things. So just click on any of the Google site and then type Flume user guide. Press enter. You will see Flume user guide, and look at that. Source, channel, and sink. Okay? Now, you can make it advanced. Can I attach sink as a source for another flow? You understand? Can I have multiple channels from the same source? That's possible. Tell me an example. Multiple channels from the same source. Assume that this is your Oracle database, which is a transactional system. You want a real-time feed to an Elasticsearch Kibana. You want a data warehouse feed, which is landing into a database. You want to export it into another platform, say MySQL or something for some other department. This is called multiplexing. So you can combine all those things, right? So just remember that, and what I want you to do is if you go to the site again, foroursun.com/passion, the first file, advanced ingestion to acquire data streams using Flume and Kafka. Open that document. So 3 documents I already told you to practice. This document is what we are going to do today. And we will introduce one of the very powerful mechanism along with the Flume called Kafka, which will be useful for you, for Spark, for what all we are going to do in the coming classes. So let's start with Flume. Okay, so what I want you to do, open the virtual machine, right? After this, I will allow you to do it because one you have to do. So please look at the steps first. So open the virtual machine and open the virtual machine browser. Go to foroursun.com/passion. Okay, please look at the steps. Oh, sorry, there is a spelling mistake. foroursun.com/passion, and please traverse little bit down. You will see 2 files starting with the word Flume. Don't look at the file which is having a word called old. There is a file Flume November 9 2017.tar. There is another file flumeconf.tar.old. Please don't take that one. That's an old configuration files. Take this one, the one which is having November 17. Click on that, allow it to download. Okay, Flume November 9 2017.tar. It's there in forourson.com/passion. Then go to your command prompt as usual, move that file to your home directory and then extract it tar xvf. So you can see that it will create a directory called a Flume in your home directory. Please look at that. There is a directory called Flume, and inside that you have conf, and you will have so many configuration files. So what's the first step if you want to do? What is the first step if you want to do scoop? Nothing, right? You directly write the command scoop import, scoop export, and you just pass the parameters, correct? The database parameters. Flume, you must write first a configuration file. Can you guess what will be there in the configuration file? Source, sync, channel, all that information. So let's take the first one, the simple one, example.conf. Just to explain you. Okay. There are many important things to remember here. I'm just not writing what is my source, what is my channel, what is my sync. You can see that my source, sync and channel is prefixed. That means before that word, there is another word. What is that word here? A1. So rather than writing source, sync and channel, I am writing A1.sources, A1.sync, A1.channel. Why? That A1 is your Flume agent name. So we are bringing another concept called agent. And now a little bit about agents. What's an agent? Have you ever worked with Splunk? How does any tool which wants to read the logs, how they work? You will install a software in that machine, otherwise how it will send the data to the server, correct? And that software which is installed onto that particular server to collect that particular data is called agent. So Flume, what you should do? Flume agent will work on the ab initio server, on the installer, you will install it. And that agent is the one who is going to send pop the data outside. And now that ab initio server can have multiple agents, right? One Flume agent which will go to a database, another Flume agent which may be sending the data to, let's say, internet. We don't know. So how will you distinguish the agents from one another? You should have a unique name. That's what A1 is here. You can give any name, whatever you want. So A1.sources, A1.sync, A1.channel. And now you know I am doing one more thing. As I told you, the source can be many. So I am giving a nickname to the source. Let's call the source as R1, sync as K1, channel as C1. Just 3 short names.
How many parallel content can do channels?
Depending upon your server capacity. No limit at all. So you gave 3 nicknames or short names, R1, K1 and C1. Then you are going to refer A1.sources. What is the type of R1? What is the type of K1? What is the type of C1? One by one you will define. If you're writing certification, they will give dash and you need to fill it. They will give you this particular file and they will fill some lines, the remaining lines you have to fill. And finally, you will see how they are linked. What is a channel? And you can see that the channel is linked. The source and the sink are linked by the channel C1, and C1 is a memory channel, which means that the data is going to go from the source to the destination through the memory. Understood? So this is a typical. Please don't by heart this, just understand the structure. I don't know how to write this completely by heart. You just look at the documentation, take a sample configuration file, save as, and then edit it. That's how you should do it. Right? So what's our source here? Can you read what is our source type? Source. What is the source here? Netcat, localhost 44444. That's the port. That is a source here. What does that mean? I am going to open a port and I am going to start a process. Okay? That's my source. And my destination, can you tell me what is my sink? Logger is my sink, which means that logger means console. So, I am going to have two windows. One window, I am going to start a process in the port 444444. 5 ports. And I am going to type hello. The Flume agent called A1 in our case should take that hello, and through the memory it should transport to another window which is my console logger and should print that hello. That means my Flume is working. Source, memory is the channel, destination is the console. We'll see more examples, but first let's start with this one. Clear? So, what are the things that you need to do? You need to start a process. Can anybody say me how will you start a port and a process? Telnet. So, if you write telnet, it will be there. Unfortunately, your virtual machine is not having telnet software. So, what we need to do? So, escape. If you type, I'm going to home directory, and if you type telnet, it will tell you what? Command not found. How will you install a command, operating system command, onto your machine? Sudo yum install telnet. Why sudo? Super user. This is the first step. So allow some time and let it install. And finally it will ask you yes or no. Just type yes. Sudo yum install telnet. Look at that. It is asking you yes or no, lowercase y, and press enter. Again y, enter. And you can see everything is done, and you will get a window like this, installed telnet. Okay. So, please look at the diagram that I heard. One window I need for starting the source. One window I need for starting my Flume agent, and that will act as the console as well. So, what I am going to do? I am going to start a process. How will I start the process? Telnet localhost 1 2 3 4 5. Oh. Why is it connection refused? I think I should start the Flume agent first. Let's look at the command for Flume agent. So the user guide, I think the user guide is having that command. If you come down a little bit, This is what I have explained to you. Yes. Look at that command. Flume ng. It is not a simple word called only Flume. What is that ng? Ng stands for next generation. They created a Flume first and they modified that Flume. That is what Flume ng. And then agent and then conf. So let's do this command. Go to the command prompt, your virtual machine. Flume ng. Agent. What's the command? Agent. Name. Minus name. And what is the name? Remember in our configuration what did we write? What's the name? A1. And then conf and conf file. Conf is the directory name. Minus conf. Where is your directory? /home /cloudera /flume /conf. Correct? That's the directory. We have untarred it. And then minus conf file. And what's the conf file? Home cloudera flume conf example.conf file. So two parameters. One is the directory and another is the file name. And please give the agent name as the first one. Okay? You should get a message that the process has been started. Enter. You will see so many messages going, and you must see created server socket, that last line. And how it started? Flume agent, you have written that my command for source is the process netcat with 44444 as the port. That's why it is starting it. Now open another command prompt. I'm going to keep it on the right hand side or on the top because I want to see the bottom part. Right telnet, and now localhost, and what's the port? 1 2 3 4 5 is the port. You are going to type something here now. Now it will tell you yes. And let's type hello, and please look below what is happening when I write hello there. Hello world. And when I press enter, the Flume agent will pick up that data and will write it to the console. Look at that. This is the bottom window. So the Flume has started and has initiated the process and has written. And now let's write something. Goodbye. Did you see? Excuse me. So instead of that process, if it is a log file, what will happen? The log file will start aggregating into your console. Right? So just do this once and then we will go to the next step. I will stop here as the very, very trivial. So I am closing this and I am going to close this one as well. Okay, clear? If you are looking at the conf directory one more time, the Flume directory, and then go to the conf directory. Next is the real one. Whatever I am going to type, hello world or whatever I typed, I don't want to come in the console. Everybody is asking what is the use of console, right? I want to write it into HDFS directly. Okay, that's what HDFS example is. And as you can see, it's very, very simple. Earlier, the destination was logger, and now what is the destination? That's all. So, you are going to change it. All the remaining things are exactly the same. And please look at this. You have to give what is your HDFS path. And what is this one? File prefix equal to netcat. It will create a file in HDFS and the file name will start with netcat. Why? Because whenever you are writing the logs from multiple systems, you need to know from which system it is coming in, right? Maybe Tableau is sending the logs, WebSphere is sending the logs, Ab Initio is sending the logs. So I will prefix it with what is the system name, so that at a later point of time, you see how much use it is. The entire world of logs can be put it into HDFS. And now you write a MapReduce program to find out how many exceptions came. Word count, exceptions. Then you can easily find out how many exceptions are there. If you export that result into a Hive table, then you create a report and then give to the management telling that last month in this many exceptions happened in WebSphere. That's the use of it. Analysis again. Are you understanding what is the use? Where it is practically used? And those guys commercialized it, Splunk. Millions of dollars. Right? Okay, so let's run this. This is going to teach you something else also. So what I need to do, go to the home directory, and wherever you run the Flume agent, this time the only change that I need to make is it's hdfsexample.conf. Remember to close the netcat and everything first, and wait till you are getting the message. Why are you getting the server socket message again? Because your source is still same. And now go here. Earlier I started it. Telnet. This time when I type hello, it is not going to appear below. See, it's not appearing. But it told you something else. It created some directory in HDFS. And now I am going to write world. I am going to write hello. I am going to write world. Hello. See, nothing is happening. Can you tell me why nothing is happening? Then now something happened. You know why? It will wait till the block size is created. And once that enough size is created, then it will flush. It is not going to flush every line. So there will be little lag, near real time. Okay, I'm going to close it. And I'm going to close this one. Clear? Hadoop. fs minus ls slash user. What is the directory name? So directory name user slash cloudera slash Flume. Okay, so slash user slash cloudera slash Flume. See, 2 files it created. What is the file name? Netcat. Why? Because you mentioned that the prefix is there. Now the problem is this. Let's try to print and whether I am seeing that hello world or not. Oh. Paste. Why? It's encrypted. It is written as a sequence file by default. Flume will write it as sequence file. What you need to do if you want to overcome is that, please look at the example again. There is another file you can see, readable hdfs example.config. You need to just add one word in your configuration file. That's why I written it separately. Look at this. the sync type should be written as a data stream. That means really that data, however it is coming, print it as it is. Do not convert it into sequence file. Unless you write that line, you will not be able to read it. Okay. So again, user cloudera / Flume, and now you are writing it as data stream. Come out. What we want to do? Let me delete the directory hadoop fs minus rmr / user / cloudera / Flume, because this is by the old configuration. Clear? And now run this particular file one more time, but don't give hdfs example, but readable hdfs example.conf. Start it. Started the netcat. Clear? And start this one. Type hello and type world. And kill this particular process and kill this particular process. Clear? Hadoop fs minus ls / user / cloudera / Flume. No change in the file name. Copy that. Hadoop fs minus cat. Data stream. So use the data stream in order to make it readable. All right. Next example, a really real example for logs. What is the production example for a Flume? So if let's close this here. All right. So if you go to the Flume directory, there is something called reallogs.conf, and you can see Ravi note. In the virtual machine, there is a magic command they have given. The magic command name is start_logs. If you type that start_logs, what virtual machine will do? It will simulate an iPlanet WebSphere application, and it will simulate logs like so many users are accessing it. Do you understand it? Simulation. And where it will be created? In this directory it will be created. Do you know what is access.log? Access.log, error.log, etc. are iPlanet logs. Any web application which is going through a web will create that application, and that is how whole world monitors which site you are accessing. You are immediately getting that the site is not allowed. They analyze these logs. So if I show you what it is exactly doing, please look at this. I'm just copying this one and I'm opening another command prompt just to show you what it is. So if I type here start_logs, see, nothing is happening. But you know what is the command, right? Tail -f. It will show you the last part of your file. Yeah. What is happening? It is generating the logs. I told you, no? It's simulating the logs. Like somebody is logging in from Mozilla, somebody from iPhone, somebody from Firefox, like that. Very nice application. Correct. Yes. This is how the web application logs are being managed. What I want to do, you already know the place. What is the place? opt/ that directory, right? This directory. I want to take all these and put it into my HDFS. So, what you are going to do is, let's do the stop logs for now. Stop. If you do a tail minus F, you should not see anything moving now. See, okay. All right. What I need to do, as you can see here, it is written into data frame, and this is a very nice example. Why it is a very nice example? Look, it is also telling you how you can configure the date and time in your HDFS, because you are accessing the logs, right? You need to know by date. So somebody is calling and telling that, hey, on 10th of October I had this particular problem. You want to look at that log. What's the idea? Add one line, use local timestamp, and use %y, %m, %d. Automatically date will be appended. If you don't write this line, you cannot use this line. Similarly, don't forget to write data stream. And don't also forget, this is Flume log and this is the date. Very nice. So, hadoop fs minus rmr, let me delete what is existing, user / cloudera / flume. Clear? CD. Start the agent. What is that? reallogs.conf. Enter. But the logs are not ready. So what do you need to do? Just give some time. Absolutely, anywhere. You have to install what? Flume agent. All right.
How will we know that Flume to install
Ask the admin team. Yeah, you ask them which servers are there. So stop logs. Don't forget to write stop logs, otherwise it will be clogging your server. All right. Stop this. See, it created a directory inside the Flume / with today's date, because I wrote YMDD, right? Amazing. It has clearly gave me this file on this date and at this particular timestamp. Copy. All the logs as plain text. Can't you not export this into a Hive table very easily now? And once you get into export into a Hive table, use your BERT, create the analysis. So that's part 2. Please do this example. It's an author name and a guy named J. Krups. When he joined Twitter, he saw something very, very complex in the architecture at LinkedIn, Twitter, etc. And what I would suggest, take a printout of this. Everything about logs that a software programmer should know. J. Krups. This is the search string. Everything about logs a software programmer should know. Please do take a printout of this and read it completely. Press enter. See the first hit, the log, what every software engineer should know about. It is written by J. Krebs in December 16, 2013. And you click on that, you will see this. Please spend some time. It's a very, very nice and long written document which contains lots of things about LinkedIn, and this is what he has seen when he joined. So many databases, so many systems. Every database is sending the data to every system. Every other system is receiving the data. Completely spaghetic, not manageable, where the error is. So what he created? He created something called a unified log. Every system will write to that, and the other systems will consume from that. He decoupled that architecture, which you already know what is what MQ is doing. IBM MQ. Any message you put it into MQ, that is called publishing. Anybody who is receiving the message, that is called subscriber or consumer. And JMS came in, message driven beans came in, extra. Yeah.
Is that unified like a distributor?
Yeah, it is completely distributed log.
So replication?
Everything they have made, right?
But we had messages queues long back, right?
Yeah, long back it is there.
He used those concepts.
He used those concepts but built with the big data technologies in mind, where replication, everything he handled. Okay? Now, then they changed the name. Since you are writing something, it is like an author. So he selected Franz Kafka's name for this particular thing, because everything is about writes and reading. That's why I think it's the only tool in the world where which is bearing the name of an author, software tool. So he named it as Kafka. So if you search another topic, Kafka hits and this is what I wanted to show you, which is a news in 2015. And that made it so powerful, so widely used, that now cars, sensors, anything, IoTs, everything is sending messages to what? Kafka. And Kafka is receiving it. No failures at all. Completely built on big data. Replication, fault tolerance, everything has been built. 1.1 trillion messages per day. If you are doing it in using MQ, you may need some 1,000 queues clustered together, and the cost of that infrastructure may cross 200 million. And you know how many systems this took? Can you guess? 3 computers. $20,000. That's the power. Okay, so Kafka is one of the very, very prominent tools now in the industry. In our company, the ingestion framework that they have created is completely on Kafka. The domains will put the message to Kafka. The data platform will receive that and will put it into Hadoop or HDFS. That's what is called as ingestion framework. It is built on a tool created by a company called Pareto Systems. They bought the source code. I was a reviewer of that last 1 year before. So this is an amazing tool. And Flume can read source as Kafka and sync also as Kafka, so that you can take a message from one messaging queue and put it into another queue. Understand? And lot of Flume users. So today sensors and everybody is using Kafka for it. So let's start installing Kafka today. And tomorrow we will see how it is used in practice. Very, very important. Okay. So what you do is, again, take back that document which I have told, because Lakshmi has asked a question about foroursun.com/passion about this one, about the fault tolerance, right? foroursun.com. And if you read that particular document, Advanced Ingestion Tools, Flume Kafka, I have written a Kafka introduction there. Okay. If you come down, you will see that Kafka introduction where how Kafka is being used. This diagram taken from the article that just I have shown you. What is Kafka? And please look at this diagram. This is answering your question, Lakshmi, that whenever a producer is putting a message, it is divided into many brokers, and as you can see, each partition is duplicated, so that one primary broker will contain your data. If that broker is losing or stopping or failing, automatically that data is available in the other machines. Exactly the Hadoop architecture. Then it will be going to the consumer. So you will see the ideas like broker, topic, etc. in Kafka. What is the topic? Queue name. You need a queue name, right? To put a message in. MQ is called a queue name. So that's called a topic. And who coordinates all these things? You remember one of the most stable package in the Hadoop ecosystem, I told you many times, Zookeeper. So Zookeeper is the one which manages the coordination between all these things. So Zookeeper is a must. You will see that I have to run Zookeeper if I want to start Kafka. Okay? And then you can start doing it. You see how the partitions are there, how the partitions are copied, right? So copy the Kafka download, directly click on the link. Don't take any other version. So this is a version, I have to open it in the virtual machine. Okay, so I'm going to the virtual machine.
First one. Advanced ingestion.
Oh, it is so big. Okay, the first one, and click on that download link.
Page 11.
Page 11. Thank you. Yeah. And click and save. All right. Once it is downloaded, we are back. Move that to your home directory, tar xvcf and it will create a long directory name called Kafka something something something. See, this is a directory name. So let us rename it to Kafka 211 short. Move to Kafka 211. As I told you, Zookeeper is a must for starting Kafka. Zookeeper is always running in a port called 2181. Let's see whether it is running or not. When I click on stats, you can see that Zookeeper is running. Telnet has got a beautiful feature. After typing Telnet, you type the word stats. It will tell you what is running on the port. Nobody knows it. So Zookeeper is running. So you don't have to start. So don't have the assumption that I don't start Zookeeper. Zookeeper is already running in the virtual machine. Alright. If Zookeeper is running, we have done half the work. CD, Kafka, 211. And I am going to start the Kafka server like MongoDB server. How will you do that? Bin slash Kafka server start config slash server.properties. This is the command to start Kafka server. Okay? Start it. You should get a message started. And I am minimizing this window. Now I have to create a topic, a queue name. CD, Kafka 11, 211. How will you create the topic? There is a command. Go back to your document. And look at the first command. Copy. I'll type it and I will paste. See, it is doing like this. Bin slash Kafka create, right?
Hyphen topics.sh.
Yeah, topic.sh. Create minus create. Okay.
Minus zookeeper. Space localhost. Colon 2181.
Right, because the Zookeeper host, I told you already, it is running. Then
Hyphen replication.
factor
Factor
1. So in a virtual machine, replication is 1. Okay, then
hyphen function
topic, and now you give the topic name. So I am going to give the topic name as, let's say, passion, just for example. So understand, this is how you will create a queue or a topic name, a pipe for containing your data. Press enter, you should get a message, topic passion creator. Now you are going to put messages into that. There is another command. Can you please help me? Producer.sh. Producer is the one which is putting the messages. So what is the command? Bin slash producer. Yes. Producer.
Kafka console producer.
Correct. Console producer.sh. Hyphen broker.
List. Broker list.
Broker dash list. Yeah.
Localhost.
9092, right?
Yeah. Hyphen topic.
Localhost.
Colon.
9092.
topic and name of the topic.
So which topic we want to put the message? Passion. And let's put hello. Let's do word. And I am going to open another command prompt. And I am going to keep it down. Very nice one here. And let us run the consumer now. CD Kafka 211 bin slash Kafka console. Yeah, instead of producer now consumer.sh. Bootstrap. I want all the data from beginning. See, I typed it 2 minutes back. It's already there. And now you see the fun. I have to minimize this. Right? So top window you observe, right? This you give 1 trillion messages now. That will show you that 1 trillion messages. In one virtual machine. In one virtual machine I tried about around 6,000 messages per second. It was running without any problem. This is Kafka. Now I typed this message instead of typing cars and Teslas and all these kind of things. That's what they will do. They will send the message to that topic, which is in the Amazon cloud. And a program like Flume or Spark will consume that, run analytics, and will decide decisions. This is the real-time world of big data.
Producer will only writing the message, giving message to client.
Yes, that is just an example. I will really show you how to create it. It's clear? We will use it tomorrow. Don't worry. Can you please install it after going home? All the steps are there. Right? Just install it and keep it ready. And Control C.
Do we need to use
Control C. What's that? Sorry?
Do we need to use stats after running that command, right? Stats. Stat means it will show the after starting the Kafka server.
No need to start. I did it.
Stats.
Stats is for zookeeper to check. Yeah. Okay. Make sure your server is stopped. Don't make it corrupted. So your server is running. Control C. See, shut down the Kafka server. That message should come. Otherwise it will get corrupted. Problem. Now, if I start consumer, after starting the Kafka server, if I start the consumer and if I look at the topic from the beginning, will the messages be there or not? Yes, it will be there. It's persistent. It will not miss any message ever. So while retrieving, if you want to avoid duplicates next time, what you should do? You should have a timestamp. And then you should check whether it is read or not, correct? Or Kafka is providing you another facility called checkpointing. It will do the checkpointing for you. In Spark we will see that. Okay?